Good morning, everyone, and happy Friday. Today, Lucian and I will be presenting to you about the Alps. Okay, so what are the Alps? The Alps are large. Oh, I have to share back there. I'll do that. Let's see. Airplay. This is PC 205, right? Oh, screen went dark. Oh, there it is. Okay, so what are the Alps? The Alps are a large mountain range in the middle of Europe. In fact, they are the highest and most extensive mountain range system in Europe. They are about 1,200 kilometers long and 250 kilometers wide, and they cover 200,000 cubic kilometers and spread over France, Monaco, Italy, Switzerland, Liechtenstein, Austria, Germany, and Slovenia.
Now you may be asking, what is the composition of the Alps? Well, the Alps are mainly comprised of three different rocks. Gneiss, which is a metamorphic rock, and as you can see right there is the top rock. Granite, which is an igneous rock, meaning that it comes from magma, which is the middle rock. And limestone, which is a sedimentary rock, as you can see the bottom rock.
Okay, so what are those, what do those words mean? Well, there's three types of rocks, which are igneous, metamorphic, and sedimentary rocks. And igneous rocks are rocks that, are rocks that form from magma, and they can be either intrusive or extrusive. And what intrusive rocks are rocks that are igneous rocks that cool slowly underground, and when they form very large crystals because they have time to cool, and the crystals have time to grow. And extrusive rocks cool on the above ground, and they have very small crystals. So igneous rocks can also be mafic or felsic. Mafic rocks have a dark color and low silica content, and felsic rocks have a lighter color and high silica content. So, oops, that's the igneous rock.
They're showing, they've put their screen. Yeah. I don't know if it, oh, that's it. Does that make it? No, that's more people. Put you in gallery. Now we can hear.
Here it is. Okay. Did we like miss everything? No, you're good. Oh, we're good? Okay. So you all heard igneous, right?
Yeah.
Okay.
Metamorphic.
Onto metamorphic rocks. These rocks form from heat and pressure. So they're just other rocks that have been heated and pressurized, and the chemical composition has changed. They can be foliated or non-foliated, and foliated rocks have aligned mineral grains, giving the rock a striped appearance, and non-foliated rocks do not have aligned crystals and often indicate lower pressures. So the third type is sedimentary, and these form from layers of sediments. They can be clastic or non-clastic. Clastic rocks form from fragments of smaller rocks, and non-clastic form from organic or evaporative.
And the first rock up in the batting order is gneiss. Although it has a G at the beginning, you only say it like nice, like nice. So it is a metamorphic rock, as discussed before by Timothy. That means it is formed by heat and pressure over a long period of time. It can be black, white, pink, or gold colored, as indicated by the three pictures of gneiss. It is foliated, meaning that it has striped layers, as you can see. It is coarse-grained. Now you might be asking, Lucy, what the heck is a coarse-grained rock? Well, fret not, my fellow viewer. It is because that means that it is not smooth and it is coarse to the touch. It is hard, which means obviously it's a hard rock. It is not soft, and it's made of feldspar, quartz, and mica.
Okay, on to granite, second type, or the second rock that you saw. And this is This is an igneous rock, and it has pink, or the color is pink or white, and it has black and white spots in there. It is a felsic rock, as you can see. It's light colored. You can see, guys, light colored, right? And it is an intrusive rock. So it formed underground, and you can see all the very large crystals, which are the black and white spots. This is also a coarse-grained rock. It is very hard, second to diamonds in the natural stuff. And it is made of quartz, alkali feldspar, and plagioclase.
And finally, the last rock that the Alps are mainly comprised of is limestone. It is a sedimentary rock, which means that many sediments, meaning sand, gravel, pebbles,
No. It's like shells and that stuff.
shells, sand, over a long period of time settled and cooled and then compressed down. It can be white, yellow, gray, blue, beige, or cream colored. That's a lot of colors. It is non-clastic, which means that it is organic and is formed of the shells of many, many dead animals and sea creatures. It is dull to pearly. Some forms of limestone can be dull, as indicated by the colors right there. Others can be a sort of pearly. It is 2 to 4 on the Mohs hardness scale, which means that's not a lot of hardness, meaning that you can scratch it with a penny but not your fingernail. And finally, it is made of calcite and aragonite, which are both organic materials.
So here's our timeline of how the Alps formed. 275 million years ago, Pangaea completely forms, which is the supercontinent, the last supercontinent. 220 million years ago, Pangaea splits into Laurasia and Gondwanaland. Then 160 million years ago, the Tethys Sea expands and the Tethys Plate subducts under Europe. 66 million years ago, the dinosaur-killing asteroid hits Earth. Now this time the Alps are underwater. 40 to 23 million years ago, the African and European plates collide, and the Alps grow by 0.1 centimeters every year. And 2.6 million years ago to 10,000 years ago, there was an era of progressive cooling in many ice ages. And today, in the present, the Alps have the current appearance resulting from much erosion and weathering.
First, let's talk about 275 million years ago. Man, that's a lot of time. So, 275 million years ago, this supercontinent, dubbed Pangaea, was completely formed in its entirety. As you can see, there are a few pictures of Pangaea. Just basically imagine all the continents together. And a supercontinent is a noun, is a giant continent made out of all the 7 modern-day continents.
Okay, on to 220 million years ago. 220 million years ago, the supercontinent Pangaea broke up into the supercontinents Laurasia and Gondwanaland due to internal heat that resulted in convection currents in the mantle. And what the convection currents did was it pushed Pangaea apart from the inside. Okay, so an ocean called the Tethys Sea separated the 2 supercontinents, and that grew at 2 centimeters per year at that time. And also at this time, the rocks that form the future Mont Blanc, which is the tallest mountain in the Alps, are part of the Laurasian continent, and the rocks that will form the Matterhorn, not the Matterhorn in Disneyland, the Matterhorn in the Alps. They're part of the Gondwanaland continent. So maybe something will happen.
And now we have 160 million years ago. We're time traveling forward at an accelerating pace. So 160 million years ago, the Tethys Sea in the middle of Laurasia and Gondwanaland continues to expand. The Tethys Plate subducts under Europe. As you can see right there, as the Tethys Sea continues to expand, the Tethys Plate subducts. Pretty simple.
On to 66 million years ago. That's when the dinosaur-killing asteroid hits Earth. But how is it important to the Alps? Well, at this time, the Alps were underwater, which is why much of the rocks in the Alps are formed of sedimentary limestone. Remember, that's from like all the shells and oysters and stuff that have died. Yeah, they died. Okay.
Now, although the Alps are somewhat made, but they're still underwater. So 40 to 23 million years ago, the African and European plates collide, as you can see with the picture right there. At this point, the Alps grow by 0.1 centimeters every year, or 1 whole kilometer every million years. Isn't that insane?
Okay, 2.6 million years ago to 10,000 years ago. This was a period of progressive cooling and ice ages. So there were many cycles of glacial growth and retreat, and the cycles were made of 100,000 year glacials, which are cooler periods in which glaciers advance, and these were interspersed with 15 to 20,000 year interglacials, which are warmer periods in which glaciers retreat.
And finally, we arrive at present. Nowadays, because of the constant weathering and eroding that the Alps have undergone, especially during the ice ages, rock slides are extremely common, giving way to the iconic steep-sided rock and mountain faces commonly associated with the Alps mountain range. I can imagine myself just relaxing there on top of a mountain, hearing the yodelers yodel off in the distance. Amazing. And those are our sources. Thank you so much for listening to us. Do you have any questions?